All right, so last time we were talking about classes. And at the end, I said there were three logistical details that I wanted to cover before we would be done talking about our introduction to classes. We got through two of them. We talked about constructors. We talked about splitting your code up into 3 files. So we have one more item left to talk about today, and that is the use of the word const. Const is really interesting in C++. It sort of has a reputation as one of those things that C++ does that's just super complicated, and some people think it's really important. Other people think that it would be better if we just didn't have it. The creators of Java are actually in that camp. In Java, there is no such thing as const. There's something called final that is sort of related, but really different. But as you've seen in C++, there's this philosophy that if a function isn't going to change something, we need to have a way of indicating that so that everybody knows. Okay, so that's the bottom line of what we're talking about today. Let me just maybe actually type that into the notes here. I'm going to say in C++, the philosophy is that if a function is not intended to change something, we better say so. Okay, that's my very informal way of stating it. Anybody want me to talk more about that, or is that pretty clear?
Could you?
Sure. So the first place we see that is with pass by value and pass by reference, right? The default is pass by value. You should always use pass by value if you can. You just put the ampersand on and make it pass by reference. Oops, that shouldn't be there, actually. You put the ampersand, you put an ampersand on and make it pass by reference when you have to, because the function changes something that needs to be sent back to the calling function. So the reason for that, there's two reasons. One is just sort of safe programming, right? If a function is not intended to change something, then we're going to enforce that. We're going to make the compiler tell us if the function accidentally changes something when we didn't intend it to. So that can help with debugging. Like if I accidentally change something in a function in Java, I'm going to have to track down that bug myself by going into the debugger and watching what's happening. If I make that mistake in C++, the code won't have compiled. The compiler will tell me, you said you weren't going to change anything in this function, but you tried to change something. So reason number one is I would call it safe programming. Reason number two is self-documenting code, right? If we're trying to understand some code, we see a function call, and we know right away that that function call is not going to change any of the arguments, then that can save us a lot of trouble, right? We don't have to go down and look at the function and see what's going on. We can move right on to the next function call because we know that it's not going to change anything. All right. So all of that talk about why we have this philosophy is not critical. The critical piece is just that you understand what we're trying to do. We're trying to make it so that if the function doesn't change anything, we have some way to indicate that. So the first time we saw that was we just use pass by value when we can instead of pass by reference. Then when we were talking about arrays, And I said, well, arrays are always passed by reference automatically and you don't put an ampersand there. But what if we don't want the array to change inside that function? And then, so at that point, we talked about putting the word const in front of the array in the parameter list to make it so that I cannot change the array inside the function. So that's kind of review. If there's a request, we could actually go back and look at that section of the lesson where we did that with arrays, if that might help understand what's going on here. But otherwise, I think I'm gonna plow ahead. And I think this will be okay if this is a little fuzzy right now. I think you'll see what I mean as we go. Okay. So what we need to talk about right now, there's two different possible things that could change when we call a member function. Okay, so the first thing is when a member function does not modify the calling object. So a member function can change the calling object. The simplest example is probably, well, let's go with set, right? The set member function, what it does is it changes the value of the calling object, right? It sets the calling object to be equal to whatever these parameters are. Okay, so the point here in part one is when a member function does not modify the calling object, we're going to put const at the end. Okay, so now here's what I'm doing. I should have explained this before. I hope this isn't too confusing, but I decided that I'm going to kind of start at the end. Okay, so these two rules right here, whoops, represent where we're going to end up at the end of lecture today. Not necessarily at the end, but when we're done talking about this topic. So if it doesn't make sense, it's not going to make sense right now, and that's okay. I'm just going to put these out here. And so then hopefully later on, it will help us kind of focus in on what we need to be understanding, okay? So just giving it a try. I'm welcome to your feedback if you say, that really sucked, it was a terrible idea. But here's where we're gonna end up. When a member function does not modify the calling object being the key word there, we're gonna use const at the end, and I'll show you how in a second. Second thing is, do not pass an object by value. When you pass an object as a parameter and you want pass by value, use const and ampersand instead. And again, that isn't going to make any sense right now, what I mean that I want you to do, but I will show you that in a minute. Okay. But by the time we are done talking about this topic, those two sentences, I guess it's 3 sentences, that's what you need to understand. Okay. Anything else we talk about is fluff. Okay. It might be useful a little bit. It might be something that's nice to understand, but this is what is the core. Okay. Let's look at our client code here. And I will try to start showing you what I mean by all of this. Actually, well, no, I'm not going to go to the client code. I'm going to stay right here. The first thing I want to do is I want to go through all of my functions and determine which ones do not change the calling object, or maybe to be slightly more precise, which ones are not intended to change the calling object. Okay, so first, the constructors. Do the constructors change the calling object? I'm going to just tell you the answer on that one. The answer is, well, yeah, that's what constructors do, right? Constructors initialize the calling object. So what that means is we are not going to put const at the end on the constructors. Okay. Probably would have been clearer if I had started with an example where we do put const at the end, but just bear with me for a second. Okay. All right, so I'm just going to keep going down my list of functions here. Now I want to look at the function print. So the question is, does the print function modify the calling object? All right, I have 2 votes for no. Okay, just in case anyone's not clear on that, let's take a look at the client. All right, so the question I'm asking is, okay, for example, right here, when I say date1.print, do I want the value of date1 to change? The answer is no. I want the value of date1 to be printed on the screen, but the actual value of date1 is not going to change. In other words, if I were to say date1.print twice in a row, I can be guaranteed that that's going to print the same thing twice in a row, right? Any questions about that? So what that means is, and here's where I'm finally going to actually show you the syntax, okay? I'm going to put the word const here at the end of the function header. And what that const means is that the calling object cannot be changed. Okay, so we're going to keep going through these functions. So if it's a little fuzzy, you'll have some more opportunities to kind of clear that up. But anybody want to ask a question before I keep going? Okay, let's keep going. How about read? If I call read on a calling object, is that supposed to change that calling object? So for example, right here, when I say date2.read, should the value of date2 change? Anybody want to, if you don't know the answer and you want to articulate a question about how to understand the answer, that would also be fine.
No, it doesn't change.
So, okay, so right here, I printed date2, right? And it was 2/28/1976. Does that make sense so far? Should I run this so you can see it? When I say date2.print there, what it's going to print is 2/28/1976. Anybody want to see that? Okay. Here I say date2.read. And then here I say date2.print again. Is it going to print 2/28/1976 or is it going to print something different? Okay, I'm being intentionally slow here because this is like super important, and I'm not quite sure what the misconception is, but I want to get to the bottom of it before we keep going. All right, let's try this. Okay, I'm going to run this. Hopefully I didn't introduce any compiler errors. Oh, actually I did. Hold on a sec. Let's go back to what we had before when I didn't have the const here. Oh, wrong file. Right, okay, so this is exactly what we had before our discussion today. And so to the bummer, what did I do? Oh, I have to date.cpp. Okay, I forgot to change something else. Sorry about this. I will fix this and then I'll start us over again. Okay, so what we're doing here is I want to see whether the read function is going to change date 2 or not. By the way, as we're doing this, if you want to go ahead and throw your thoughts into the chat window, that's totally fine. The more feedback I get on what people are thinking at this point, the better. What we're trying to do is figure out, when I call date2.read, does that change the value of date 2? Okay, so if you're not sure, so the answer to that question is yes, it does. If that's not clear, then I don't think you understand what the read function does, right? The whole point of this statement is we want to read something that the user enters and put whatever the user enters into date 2. Right? So going back to my attempt to run it here. Okay, so when first declared, date 2 equals 2/28/1976. Okay, now I'm down here in my program. The next thing that's going to happen is I'm going to enter a date. And what several of you are saying is that when I print the date, it's still going to say 2/28/1976. Right? So if I enter December 14, 2035, you're saying that date 2 is still going to equal 2/28/1976. Well, no, look, the date you just entered was December 14, 2035. So when I called date2.read, the value of date 2 changed. Anybody who was confused before, get it now? Anybody want to say you still don't get it? Anybody want to say you got it? Okay. Okay, so I guess I'll go with that. So, and I don't mean this in any facetious or critical way at all. It would help me in my teaching if I could understand more about what the confusion was there. But we don't need to talk about that right now. Just maybe, shoot me an email later and say what was going on. But anyway, I'm going to go with that. We all agree now that the read member function is supposed to change the calling object, right? So what that means in my class is, that means I'm not going to put const right there because I want to allow it to change the calling object. Let me put the const back here. Okay. All right, ready to move on to the next function?
Quick question. So
Yes.
Is the const just like a preventative measure just in case print does change it? Or
I'm going to say yes for now.
Okay.
That's the best way to think about it. It's just preventative. That's what I meant when I said safe programming, right? It prevents print from accidentally changing something that it's not supposed to change. I also said that there's another reason, right? It's a self-documenting code. It clears something up for the reader, right? Someone reading the code knows that the print function isn't going to change the calling object.
Okay.
The other thing, just to throw it out here, I don't want to digress in this direction right now, but I could actually put some code in my client that will not work correctly if I leave the const out. So I don't want to go there just yet. I'm just kind of throwing that out there for now. It's primarily preventative and just, good practice, but I can break the code if I really want to. And if you remind me, I'll show you that when we get a little further along. Okay, so we've looked at the first four functions. Let's look at set. Is the set function supposed to change the calling object? By the way, I really appreciate those of you who are answering my questions, even if you get them wrong, actually, especially if you get them wrong, right? Because if you get them wrong, that tells me I need to talk about it more. So really appreciate anybody who's willing to stick their neck out and answer the questions when I ask them. Yeah, looks like everyone's got it now, right? The set function, the whole point of the set function is to give the calling object a new value. So what that means is we're not going to put const there at the end of the set function. Okay, comes before. So if you don't remember the comes before function in detail, we might need to go back to the client program to sort of refresh our memory about what it does. Okay, there's how we call it. When we call the comes before function, are we intending to modify the calling object? Okay, excellent. So I've got 4 votes for no, and that is in fact the correct answer. In this case, we do not want the comes before function to change date 1. The comes before function is just supposed to return true or false. It's not supposed to change anything. So that means that, whoops, that means that comes before is going to have const. Good. Seems like we're getting better. Let's look at increment. Again, if you remember exactly what the increment function is supposed to do, you may not even have to go look at the client code, right? If you remember, let's see, what does the increment function do? The increment function increments a calling object. So just from that sentence, you should know, is it going to change the calling object? Yeah, obviously, I just said it's going to increment the calling object. That means it's going to change the calling object, right? And just to verify, in case you're not sure, we go look at the client and we see where it was called, date2.increment. The whole point of that line of code is that we want the value of date2 to change, right? So great. We're not going to put const there. Definitely seems like we're getting the hang of this. How about increased by? So before we go look at the client, let me just state what it does. The increased by function advances, I have to say this very carefully. It returns a value that is equal to the calling object advanced by num days. Okay, so that we got to be careful on this one. Is that going to change the value of date2? Okay, so this is kind of a tricky one. But look at what I test next. I say, after setting date1 equal to date2 plus 12, date2 is still blank. So what I'm checking there with those 3 lines of code is I'm checking to make sure that date2 has not changed, right? What this does is it returns. So if date2 was January 1st, 2000, then after this statement gets executed, date1 should be January 13th, 2000. but date 2 should not change. Right. So Erica said, you're changing date 1, not date 2. If you're referring to this whole line of code, the answer is yes. This line of code is changing date 1 with the assignment operator. But just to be clear, increased by isn't changing date 1, right? Increased by isn't changing, the increased by function isn't changing anything. All right, so anyway, point is the increased by function does not change date 2. Just, I'm going to say this one more way in case it helps anyone who's still a little fuzzy on this. Basically, the analogy to that line right there is if I had integer variables named I and j, and I said I gets j plus 12, right? In that case, I'm not expecting the j to change, but the I will have a new value when I'm done. Okay, that's the analogy to what we're doing here. Date 2, this is like saying date 2 plus 12. Okay, so hopefully that makes sense. The value of date 2 is not going to get changed, so that means that the increased by function will be const. Okay. How about num days and month? So the num days and month function just looks at the calling object and returns how many days there are in the month. Does not change anything. So that's const. I'm kind of thinking that you sort of tracking with me now, so I'm going to do the last two a little bit more quickly, but feel free to stop me if you want me to say more. Is leap year, same thing, right? The only thing the is leap year function does is it looks at the calling object and it returns true if it's a leap year. It doesn't change anything. Okay. All right, so I think I've put const in all the right places. Now, of course, I have to do this on the actual function itself also, right? The function definition. So let me go to the function definitions. And let's see, increased by was const, right? Is leap years const. Num days and month is const. Increment was not const. You can also tell, and just another way to double check is, inside this function, I have day plus plus, right? That means the calling object is getting changed. So it should not be const. Comes before is const. Print is const. Read and set are not const. Okay. So let's go ahead and test this out, see if we did everything right. One thing I will say about using const like this is you have to be consistent, right? If you're going to get the const right some of the time, you have to get it right all the time, or it's going to actually introduce syntax errors. So let's see if we got it right all of the time. Looks good. Okay, I'm not going to run it because basically, as long as it compiles, it should still run the same. Okay, that's all I have to say about that use of the word const. If we have time and you want me to a little bit later on, I can show you how I can break the code if you don't use const, but I'm going to just leave it at that for now. Any questions before we move on to the next use of the word const? Okay, so what we were just talking about is part one. Hopefully this should make 100% clear sense now. When a member function does not modify the calling object, use const at the end. Okay. Next thing we need to talk about. Do not pass an object by value. I'm I'm going to explain a little bit about why that is, but invariably, every time I do this, students start to get confused. So I just want to say from the start, if you don't understand what I'm about to say, that's okay for now. Just follow the rule. Do not pass an object by value. Okay. And then just backing up a little bit, is an int an object? All right, I'm just going to answer that. No, an int is not an object, right? When we are using the term object, we mean a variable that is a class, right? So a string would be an object, a date would be an object. When you write your assignment for this week, a fraction will be an object, but things like int and char are not objects. Okay. Do not pass an object by value. When you do pass an object as a parameter and you want pass by value, use const and ampersand instead. So here's how that's going to go. Do you see any place in this list of functions where we are passing a parameter, passing an object by value? Is there an example of that in this code that's highlighted? Or let me ask that another way. Is there an example in this highlighted code of a parameter that is an object? Okay. So I want a few of you comes before. Okay. So this is another one of those moments where I wish I knew what the missing piece was. Let's look at comes before. Here's a parameter, right? Is that parameter an object? Right, that parameter is an object because date is a class, right? Date is a class, that makes that parameter an object. So the conclusion so far that we have come to is that right there we have a parameter that is an object. I would love to hear from anybody who could explain to me what was confusing about that question, or what made you not sure about that. But if you're not able to articulate that, that's okay too. I'm just curious, because it would help me know what's missing. Okay, everyone okay with that? There's a parameter that is an object. Hearing nothing, I'm going to assume that that's a yes and everybody's clear on that. Okay, so the first part of this rule is don't pass an object by value. Is this passing an object by value? Yes, it is. That is passing an object by value. In C++, parameters are passed by value unless you put an ampersand there, right? All three of these are passed by value. All three of these are passed by value. This is passed by value. And just in exactly the same way, this is passed by value. Okay, any questions about that? I'm really happy to stop and answer questions. This is like super important. I just want to make sure we get this. The rule is do not pass an object by value. Right here, we have violated that rule. Any questions, or anyone want to just say you got it?
So passing an object by value, that's different from putting the constant part.
That is completely unrelated to the const, yes.
Okay.
No connection whatsoever. Why does it work then? Why would it not work? Okay, oh, well, okay, so let me, I think I understand what's behind your question. Do not pass an object by value does not mean that your program won't work if you pass an object by value. I'm just saying that it's bad practice. It'll still work. Most of the time, okay? I'll explain why it's bad practice in a minute. Does that answer your question, John? I'm guessing, I'm just sort of guessing that's what was behind your question. Okay. Okay. Anyone else?
Yes, I do have a question.
Mhm.
So when we say do not pass an object by value, so in this case, like it's working because we do pass it by value, right? It's working because it's not modifying the value, like it's not modifying, like the function is not changing anything.
Right. So
That's why, right?
well, I guess my point is that's not the issue here. I mean, it sounds like you're expecting that if I pass it by value, the program's not going to work, but I'm not saying that anyway. This has nothing to do with whether something's changing inside the function or not. I'm just saying, as a matter of good practice, you know, so we wrote the class, we're done writing the class, everything works fine, we're happy, okay? But I'm going to just say, as a matter of good practice, don't pass an object by value. Even though it works when you pass it by value, don't do it. I guess maybe it's hard to accept that statement without me telling you the why. I was kind of hoping that I could just tell you the rule and everyone would say, okay, cool, I like that rule, I'll go with it. But it kind of seems like if I don't tell you the reason behind it, it's more difficult to accept. Or at least that's my current theory. What passing anything by value is? Well, when we first learned about parameter passing, remember we were talking about the drawbox program, and I had a function named draw horizontal line. And I had to, when I had to send it a value, how many X's to print, right? So I had, you know what? I think it's going to be too confusing to switch examples here. So let me just erase the last sentence or so. Let's look at this case right here. Okay, I have an increased by function. I have a parameter int num days. What that means is that when I call the increased by function, I am sending it information and telling it how many days to increase by. Okay. That when I first presented you with parameter passing, that's all I said. I said, whenever you need to send a value to a function, just declare the variable right there in the parentheses, and that'll work. Pass the value. So pass by value is the basic, more fundamental technique of passing a parameter. Later on, I said, oh, well, wait a minute. What if the called function needs to send information back to main? This mechanism won't work. Instead, I have to use pass by reference. Okay, so but pass by value is anytime that I am a function and I'm just receiving information. Right? I don't know if that helped. Is there a different way I could answer that question that might help more? Because you're right. If pass by value and pass by reference is a little fuzzy right now, this is all going to be way harder. So I'm happy to spend some time going over that again. Any questions? Okay, so bottom line here is, I mean, there's no ampersands anywhere in these parameters, right? So that means everything's passed by value, including this. And the sentence that I am getting to, the bottom line here is simply do not pass an object by value. And what I'm about to tell you next is what to do instead, right? So in the case of the comes before function, we want the parameter to be passed by value in the sense that we don't want it to change. But because of this rule, I'm saying don't pass it by value. Instead, you have to pass it by reference. Okay, and I'm gonna get around to explaining why there is that rule in a minute. But first, I just want to tell you what to do instead. Okay, so instead of using pass by value, I'm going to use pass by reference. But this violates the C++ philosophy that if a function is not intended to change something, we better say so. Because now I'm looking at this and it looks like it is going to change the parameter. So the way we fix that is we put the constant front. Okay, so this is the final correct best practice way to write the prototype for comes before. We make it pass by reference because of this rule. And then we put the const back in front so that it behaves somewhat like pass by value. Okay. That's all you need to know, right? At the very basic level, all you need to know is when you see an object that is passed by value, put constant ampersand in there and you're done. Someone, let me know how that feels. Like, is it hard to know whether you have a situation where there is a object that's being passed by value? Is that still difficult or is that clear? I mean, in one sense, because there's this convention that classes always start with an uppercase letter, you could just look through your functions and look for any time where you see the, let me go back to the wrong version. Any place you see a parameter where the type starts with a capital letter, you know that you should just type constant ampersand in front. You could almost just, write a little C++ program that goes through your code and does that for you. Okay. All right, so if there's no questions, the only thing I still have left to do is I want to explain why we have this rule. Maybe that should have been the first thing I did, I don't know. But my argument is still, it doesn't really matter for our purposes, right? The reason is, I could just say, I'm not telling you the reason, just take my word for it. There's a good reason, and you should be just fine. But in case it helps, here's why we have that rule. It's because pass by value with an object, let me say that again. Passing an object by value is inefficient. Okay. So I think sometimes the confusing thing is students look at this and it's like this, and I say, well, don't use pass by value, instead put ampersand and const. And they're like, well, why would I put ampersand and const when that just ends up being the same thing as pass by value, right? Well, the answer is, this is not pass by value, this is pass by reference, and it's more efficient when the parameter is an object. Okay. Now I could stop there, but I'm not. I'm going to actually explain that in even more detail in case anyone is still interested, or I guess I shouldn't say it that way, in case it helps. Okay. The way that it's inefficient is that when you use pass by value, you have to make a separate copy of that argument. So if you're just passing an int by value, that's not a big deal. You just make a copy. When you're passing an object by value, the object is large. And so you use up a lot of memory by having an extra copy of it. But even more importantly, you waste processing time by having to go through the process of making the copy. All right, so there's my best attempt at giving you the reason behind the rule. Any questions? Anybody want to talk more about this? Okay, if that's it, I think we're done with the introduction to classes. I'm just gonna run this one more time to make sure that we got everything right. We can, well, I changed the comes before prototype, but I have not changed the comes before function definition yet. So let me do that. Okay, and now if I hit compile and run, should all be good. 12 for 1967. Okay. Anybody want to talk more about any of this stuff or ask any questions about anything we've talked about today? Okay. So what we're going to do now is we're going to change gears. I am done with this example. I'm going to pull up a couple more files. Actually, before I pull them up, well, I can pull up the client. Okay, so the topic, so our next topic, I think in the syllabus and in Canvas, what I call it is operator overloading. In the textbook, I think he just calls it more about classes or something like that. Okay, so it's really just, we're going to continue talking about classes and filling in some more details, but 90% of what we're going to be doing is talking about operator overloading. What operator overloading means is that in C++, we can, if we're creating a new type, like we just created a new date type, right? We can actually give the operators, things like plus and minus and times and whatever operator there is in C++, we can give it a meaning so that it will work with objects of our new type. So let's talk about fractions, okay? You're going to be working on a fraction class for the assignment that is due next Monday. So in your fraction class, you're going to have a function called added to, and it would be called like this: F1 gets F2 dot added to F3. Okay, so that's how I would add two fractions in the assignment that you are working on right now. In fact, there's probably a statement pretty close to being exactly like this one in the client program that I've provided for the lab. So the point is, with wouldn't it be great if instead of calling this awkward function like this, we could just say F1 gets F2 plus F3, right? Turns out that we can. So that's what we're going to be talking about. It's actually, you know, what you need to know about operator overloading is going to be like 2 sentences. But then we're going to spend the rest of our time talking about just doing some examples of situations that come up and how to handle them. And even more than that, we're going to be talking about how operators in C++ actually work, because in much more detail, much more depth than we have before, because we're going to need to know about them in more depth in order to overload them correctly. So bottom line is, there's the goal. The goal is to be able to say things like this. Hopefully you agree that that's a lot cleaner, right? If I have to choose between these two. And, you know, you can imagine that, what if I had something like F2 plus F3 plus F4 plus F5, right? How would I do that with this added to function? You know, I can imagine that I could probably do something, but it's going to get really messy, right? F4 dot added to F2 dot added to. I'm going to just give that a try for now. And that doesn't even include F5, right? So you can see this is going to get really messy really fast. It's going to be really nice if we can just use the plus operator the way that we would naturally expect to be able to use it. All right, I'm going to give you a little sneak preview here. The bottom line thing that you need to know if you want to overload an operator is that when C++ sees something like this, it's going to translate it into this. Okay, so what we're going to have to do in order to overload the plus operator is we just include in our class a function named operator plus that takes one parameter. Left operand turns into the calling object. Right operand turns into a parameter. Okay, so rule is, when the compiler sees something like this, it simply translates it into something like this. So what that means is that in order to overload the plus operator, we have to provide a member function named operator plus. Okay, that's 90% of operator overloading right there. The rest of the stuff is just sort of filling in some gaps. Okay, so what we're going to do in order to work on this is we're going to do one large case study. So let me show you the client code that we're going to be working on. And so basically what I'm going to do right now to get started is I'm going to spend a few minutes and I'm just going to set up an example that we're going to then work on later. The initial setup of this example is not going to have any operator overloading in it. I'm going to set up an example that does not have operator overloading in it, and then we're going to start adding operator overloading. So here's a client. I'm going to be writing a class called feet inches. This class is just going to store a linear measurement in feet and inches, right? So about the value of F1 might be 6 feet 4 inches, or it might be 12 feet 0 inches, or something like that. So you can imagine that this is a type that someone who was writing a program to, say, an architecture program, for example, where you have to have a lot of dimensions of rooms in terms of feet and inches. This would be a class that we are writing so that the person or team writing the architecture program would not have to worry about passing around 2 different values and all the different things that we're going to be, all the different features that we're going to be providing. Okay. So that's where we're headed. For right now, I just have a main function, and I'm going to start with a class that just has the functions required to make this client program run. So you can see, first of all, we're going to have 3 constructors, right? We're going to have a constructor that takes no arguments, otherwise known as a default constructor. We're going to have a constructor that takes 1 argument, and we're going to have a constructor that takes 2 arguments. Then we're going to have an added to function, and we're going to have a print function. That's it. So I'm going to write 5 functions, and then we are going to have enough to actually execute this. And that's a good place to start, right? I want to start with something that we can test and make sure it works, and then we're going to start building on it. Any questions so far? Okay, so here's my class. I'm done with it. I hope this isn't confusing, but I have decided to just go ahead and keep the class in 1 file instead of dividing it into 2 parts, just to kind of keep things simple for lecture. Oops, get rid of that. That's not there. Okay, now there's one new thing here, that at least new in the sense that I have not talked with you about it before. And that is that I am using default arguments here. What that means is, I'm sorry, I guess these are default parameters. So what that means is, if I call this function, and this technique works with any function, not just constructors, okay? If I call this function with no arguments, the compiler will still accept it, and it will just assign 0 to the 2 parameters. If I call this function with 1 argument, the compiler will still accept it. It will assign in feet to the value that was passed, and it will assign in inches the value 0. And then, of course, if I call this function with 2 arguments, both of the parameters will get the values that were set. So what that is basically is, this is exactly the same result as if I had provided 3 different constructors, 1 with no parameters, 1 with 1 parameter, and 1 with 2 parameters. I just get to do the whole thing with 1 function instead of having to write 3 functions. Okay. Any questions about what's going on there? And just as a matter of fact, just to maybe drive this home a little bit, when the compiler sees this, it actually generates 3 separate constructors. 1 with no parameters, 1 with 1 parameter, 1 with 2 parameters. So basically, this is just a nice, neat way of making it so that I only have to write 1 function, but I'm actually getting 3 functions. Okay, so here's my print function. Just see out feet and inches. Here's my added to function. I'm just creating a temporary object, setting the feet, a data member of that temporary object, to the feet data member of the calling object plus the feet data member of the parameter. Same thing with the inches data member. and then I'm returning that temporary object. And then the constructor is just doing what we usually do in the constructor, right? Initialize the data members. Any questions about any of this code so far? Okay. Let's go ahead and overload our first operator. So what that means is I want to be able to say, get rid of that and instead just simply say F1 gets F2 plus F3. Okay, that's my goal. Actually, you know what? I should just compile and run this thing so that we see that it actually does work. Okay, 3 feet 0 inches plus 4 feet 7 inches equals 7 feet 7 inches. Any questions about why this code gave us this output? All right. So now I'm going to get rid of this and I'm going to replace it with this. And what that means is going to have a function named operator plus. The return type is feet inches. The name of the function is operator plus. And it's going to have a feet inches parameter. And it's going to be const because it's not going to be changing the calling object. There's my prototype. Let me define that function now. Okay, so this is going to be pretty much the same thing as what the attitude function did, right? In fact, not only is it pretty much like, it's exactly like, right? So I'm just going to copy paste. So really the only thing we're doing differently here is that we are naming the function operator plus instead of naming it added to. All right. As a matter of fact, I could have literally just gone in here and replaced the added to with the word operator plus, and everything else would fall into place. All right, so I think I'm done here. So what's left is I just need to run this again now, compile and run this again, make sure that everything still works, even though I'm using the operator plus with two operands that are of type fraction, feet inches. Everything still looks good. Okay. Just to be clear on what's going on here, what would happen if I tried to do this and I didn't have that extra function?
You'd get an error probably.
Okay, that's a good guess. What's going to happen? Let's just see. Ooh, lots of errors. Okay, I hate it when I get this kind of error. I think actually Visual Studio does a better job of not giving you all of this garbage here. But basically, we need to go to the very top where it says invalid operands to binary expression. Right. So what it's saying here is I have an operator plus, but the operands are invalid. In other words, I don't have a plus operator that works with operands of type feet inches. Right? So anyway, that's the problem that we're solving when we create a function named operator plus. Now we can do this and we don't get any compiler errors. Okay. One other thing is that this operator plus function is now replacing this one, right? I don't need this old add or to function anymore. If I want to add to feed instance objects, I'm just going to use the plus operator. So I'm going to get rid of that. And I'm going to get rid of that. And just one more time over here to make sure I didn't mess anything up. And we're good. Okay. Pretty straightforward, right? Fun, powerful, not too hard. Any questions about overloading the plus operator like that? Okay. That's a really good stopping point. The next thing we're going to talk about is going to take way more than 5 minutes. So I think I'm just going to stop there. Any questions or comments before we stop? Okay, well, have fun in lab. Take advantage of the time to get the help you need. Get as much of a start as you can on the lab. Especially, I guess I would say, I would try to get your thing separated into 3 files, just because that's something that it may be useful to have someone there who can help you if it doesn't work the first time. But the main thing is the lab is there for you to get the help you need. All right. Any other questions? Great. I will see you next Monday and have fun in lab.
Thank you. Have a great weekend.